All right, let's jump right in. Today, we are talking about Docker. It's a piece of tech that has totally flipped the script on how modern software gets built, shipped, and run. For a lot of people in the tech world, it's been an absolute game changer. And we have to start right here with probably the most infamous, most maddening phrase in all of software development. If you've ever been on a team, you have heard this. That right there, that's the classic sign that something is seriously broken in your workflow. And it's the exact problem Docker was created to solve. So, what's behind that dreaded phrase? Well, before Docker came along, just getting a project set up on different computers was a massive headache. It was a constant source of friction and just wasted time. Let's see why. Okay, look at this. You can see how these tiny little differences just create total chaos. So you've got developer 1 on a Windows machine using slightly older versions of their tools. Then developer 2 comes along with a shiny new Mac, and naturally they install all the latest stuff. All of a sudden, the setup instructions don't work, the commands are different, and because it's all being done by hand, the chances of something going wrong are, incredibly high. And the result? Yeah, it's pretty much guaranteed chaos. You get these bizarre version conflicts, where code written for an older tool just breaks on a newer one. You end up wasting hours, sometimes even days, debugging the environment itself instead of the actual code. And this nightmare doesn't just happen on developer laptops. Oh no, it follows the project all the way to the live servers. So what's the fix? What if you could just take your application, all its code, and all the things it depends on, like Node.js and Redis in our example, and just package them all together into one single, tidy, portable little box that runs exactly the same no matter where you put it? Well, that box is called a container. And here's the absolute key. A container is a totally self-sufficient unit. It doesn't care if it's on a Windows PC, a Mac, or some server in the cloud. It bundles up everything the application needs to run, which guarantees that it will behave identically everywhere, every time. Okay, so to really get how this all works, we need to quickly break down a few key terms. And it's also super important to see how this is different from the tech that came before it. First up, you've got the Docker image. The best way to think of this is as the blueprint. It's the master plan. It's a static file that lays out all the instructions and has all the necessary ingredients. You build this image one time, and then you can share that exact blueprint with anyone on your team. Now, when you take that image, that blueprint, and you actually run it, you get a Docker container. This is the live thing, the running application. So if the image is the blueprint for the house, the container is the actual house you built from it. And you can spin up tons of identical containers from that one single image. Now, a lot of people ask, wait, isn't this just a virtual machine? And that is a great question. But nope, they are fundamentally different. A virtual machine, or a VM, has to pretend to be an entire computer. That means it includes a whole separate guest operating system inside it. That's why they're massive, we're talking gigabytes in size, and they take minutes to boot up. Docker containers, on the other hand, are way, way more efficient. They're clever because they share the operating system kernel of the computer they're running on. This makes them incredibly lightweight and super fast. We're talking megabytes instead of gigabytes, and they start up in seconds. And that amazing efficiency, it completely revolutionizes the whole software development workflow. It creates this smooth, reliable, and predictable path from a developer's laptop all the way to a live server. Let's just compare the process, right? The old way, the before Docker way, the dev team would write their code and then basically just chuck a long text file of manual instructions over the wall to the operations team. It was a perfect recipe for mistakes and miscommunication. With Docker, it's totally different. The dev team packages the entire working app into one image. The ops team then just runs that one image. That's it. No complicated instructions, no manual setup, and best of all, no surprises. So the modern pipeline becomes beautifully simple. Step 1, a developer packages their app into a Docker image. Step 2, they push that image to a central storage spot, which is called a repository. And step 3, the server just pulls that exact same image and runs it. It's the same environment from start to finish, every single time. And this whole idea of sharing images, well, it's created a massive, thriving ecosystem around it, which makes it unbelievably easy to find and use applications that are already built for you. Which brings us to Docker Hub. Honestly, just think of it as an app store, but for server software. It's a public library with over 100,000 container images ready to go. Need a database like Postgres or a tool like Redis? You don't have to build it from scratch. You just pull the official image and run it. It's that easy. And finally, Docker's real impact isn't just about making one application run smoothly. It's so much bigger than that. It has become the fundamental building block for the entire modern cloud. Here's the thing you have to realize. The big, large-scale applications you use every single day, they're not just one program. No way. They are these incredibly complex systems made up of hundreds, sometimes even thousands of individual containers, all talking to each other. Now, trying to manage all of that complexity is a huge challenge. And that's where tools called container orchestrators come into play. You've probably heard of the most popular one out there, Kubernetes. Its entire job is to manage these huge fleets of containers, making sure they run properly, scale up and down when needed, and can all talk to each other correctly. So let's end with this thought. Docker started by solving a simple but really frustrating problem on one person's computer. But by solving that one problem so elegantly, it unlocked the ability for us to build and manage software at a scale we have literally never seen before. It really makes you wonder, what comes next?